Alrighty guys, so in today's lecture we're going to be talking about something called isomers, but for this class we're going to be sticking to a specific type of isomers called structural isomers, okay? I'm going to say the word isomers, but just know that when I say that I'm referring to this specific type. There are a lot of different types of isomers, but they kind of go beyond the scope of this class. For this class, when I say isomers, I mean structural isomers. So structural isomers, they're basically compounds or chemicals, molecules that have the same formula, but they have a different arrangement of atoms. So basically, they have the same number of every single atom inside that molecule, but they're arranged a little bit differently. So we have a couple examples that we're going to go over here. So if you look at this example, we have two different molecules. Now what we're going to do is first we're going to draw the skeletal model of each molecule. So let's start with this one. Here we have a carbon on the left, so I'm going to draw a line. So that's going to be this carbon and this carbon. On the second carbon, so this is carbon number 1, second carbon number 2, you notice that there is a carbon going up, so we're going to draw a line going up. And then we have carbon number 3, 4, and 5 on the line. So we go 3, 4, and 5. So we have carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. And you're going to notice that on carbon number 2 here, we have this carbon coming out of it. Okay? So if we were to write the chemical formula for this structure, we have how many? Let's count up how many C's we have. We have 1, 2, 3, 4, 5, and then we have 6 C's. So the chemical formula would be C6, and then how many H's do we have? We have 3, 6, 7, plus 2, 9, 11, and then we have 14. So we have 14 H's. Okay, so we have 6 C's, 14 H's. Now let's draw the skeletal structure for this chemical right here. So this chemical right here is going to start off the same. We're going to label our carbon. So we have carbon 1, 2, 3, 4, and 5. So we have the same number of carbons in a row. So we're going to draw carbon number 1, 2, 3, 4, and 5. But here, if you notice, carbon number 3 is the one that has a carbon coming out of it. So we have carbon number 1, 2, 3, 4, and 5. Okay? And so if you notice, these shapes look very similar. The only difference is that on the one on the left, carbon number 2 has a carbon attached to it, but on this one on the right, carbon number 3 is the one that has a carbon attached to it. And if we write down the formula, if we count up how many carbons there are 6 carbons. And if you count up the H's, you will also get 14. We have 3, 5, 8, 9, 11, 14. So if you guys notice, these chemicals look different, but the structures are the same. So what that means is that both of these chemicals, they are called structural isomers. Okay, in this class, I'm just going to say isomers from now on, but these are isomers. Isomers are chemicals with the same formula, but they are arranged differently. They both have 6 carbons, and they both have 14 H's, but the atoms are all arranged differently. Okay? Now, the reason why this matters is because based on where the atoms are arranged, it's going to change the properties. Okay, so basically the way that we use these chemicals, the things that these chemicals do, are going to be slightly different or even dramatically different just because we arrange the atoms a little bit differently in the molecule. So we'll talk about that later in the unit, but just keep in mind that they have different properties, that they're different even though they have the same chemical formula. They're organized differently, and so they're going to have different properties. So let's look at another example of two isomers. So we have these two structures right here. Now, I know you guys have seen this before. This dashed line right here, right? This dashed line basically just means it's a single bond, but it's telling you that the bond is going in towards the paper. Okay, so into the paper. Okay, because we need to remember these molecules aren't just flat things on a piece of paper. It's not two-dimensional. Real life is three-dimensional, so there's we have up and down, but we also have in and out. And so this type of line, this dashed line means that it's going into the paper. This triangle right here is also a single bond, but it's the exact opposite. That means it's coming out of the paper. Okay, so we have a single bond here and a single bond here. One's going into the paper, one's coming out. And then we have a double bond, and then we have a bunch of singles. So if we were to draw the skeletal structure of this, we have a carbon number 1, 2, 3, and 4. So we're going to draw carbon 1, 2, 3, and 4. Okay, so we have carbon 1, 2, 3, and 4. But if you notice, between carbons 1 and 2, there is a double bond. That means that in our skeletal structure, we need to draw the double bond. Okay. Now for the structure on the right, we also have 4 carbons. So we're going to do 1, 2, 3, 4. And so we're going to have 4 carbons. But if you notice, the double bond is in a different spot now. The double bond is between carbons 2 and 3. So we're going to have to put a double bond right here. So again, if you notice, the chemical formula is going to be exactly the same. There's going to be 4 carbons and there's going to be 4 hydrogens. Okay, but because the double bond is in a different spot, these are going to be isomers. They're going to be a little bit different. So here we have all of the atoms arranged similarly, but because the bonds are different in different places, they are going to be isomers. All right, so we'll look at an example of something that's not an example of an isomer, and then we'll move on to a couple examples of questions on your assignment. So here we have something that's not an example because they're identical. So if you guys notice, we have 2 carbons. We have 1 carbon right here, second carbon here, and same thing for the structure on the right. Now if you notice, we have a carbon, or this carbon has a Cl going out to the left, and this carbon number 1 has a Cl going up. And I guess what looks different is that here is going to the right on the carbon number 2, and this one's going down. But if you draw the stick structure, you're going to notice that these are the exact same molecules. There's nothing different about them. So if this one would look kind of like this, we draw a line. This carbon is connected to a Cl. This carbon is also connected to a Cl. And if we draw this, we have a line. We have carbons 1 and 2. So I'm going to draw 1 and 2. And in the structure on the right, it's also connected to a Cl, and this carbon number 2 is also connected to a Cl. So if you notice, even though they're positioned in different places, because they're both connected with a single bond to the same carbon, carbon number 1, these are not isomers. Okay, instead, we would just say that these are identical. Okay, so the orientation or the direction in which we organize the atoms does not matter. So I can draw it like this. So I can draw Cl and then do this. This is the same thing as all of that, because if you notice, it's a single bond. It's a single bond. We could also draw it like this. We can decide to go down. It doesn't really matter which direction we draw it. If the atoms are bonded with the same bonds, the same atoms, then they're going to be isomers. Okay? Or they're going to be identical. Sorry, they're going to be identical if they're bonded the same way. Okay, so that's an example of identical atoms, and these are not isomers. Even though they look like they're in different positions, they're actually in the same position. All right, so we're going to do a couple examples that look like questions on your assignment. So in your assignment, you're going to have to do 2 things. You're going to draw the skeletal structures, and then you just got to tell me if it's identical, whether they're isomers, or if they're completely different chemicals altogether. So let's start by doing the skeletal structures. So if you feel like you can try this on your own, you can feel free to pause the video and do it. But if not, I'm going to go over it step by step. So here we have carbon 1, we have carbon 2. So we're going to draw a line, and that's going to represent carbon 1 and 2, and carbon 2 is connected to NH2, so we're going to do NH2. Okay, and again, this is carbon 1, this is carbon 2, and then in this structure right here, we have carbon 1, we have carbon 2, but you're going to notice there's an N in between them. So if we drew the isomer, it would look like this. We would have a line going down. There's an N right here, but it's connected to an H. So we need to draw that H. And then we have the second line. So carbon 1 is here, carbon 2 is here. So let's figure out the chemical formula. Okay, so the chemical formula for the one on the left, it's going to be 2 carbons, C2, so we did that. We have 1, 3, 5, 7 H's, so H7, and we have N. Here we have C2, so 2 carbons. We have 6, or 3, 6, 7 hydrogens, and 1 N. So if you guys notice, the chemical formulas are exactly the same, but they are arranged differently, right? Here the N is attached to carbon number 2, and this one N is attached to 1 and 2. So these would be an example of isomers. Okay, and they're isomers because they have the same formula, but they're all connected differently. Okay, so we're going to do a couple more examples, and if you feel comfortable trying it now, you guys can pause the video and try it on your own, but if not, it's okay. Let me just go through it step by step. Okay, so here I'm just going to label the carbons with numbers again, just so we can see them. So we have, looks like we have 3 carbons on all of them. Okay, so here we have carbon 1 connected to 2, carbon 2 is connected to an OH, and then it's connected to carbon number 3. So if we were going to number the carbons on the skeletal structure, we have carbon 1, carbon 2, carbon 3. Here we have carbon 1 connected to carbon 2, connected to carbon 3, and carbon 3 is the one connected to the OH. Okay, so this one looks like that. Now if we write the chemical formula by counting up all of the atoms, we have 1, 2, 3 carbons, so we have C3. We have 1, 2, 3, 4, 5, 6, 7, 8 H's, and then we have an O. This one right here, we have 1, 2, 3 carbons, so C3. For our H's, we have 1, 2, 3, 4, 5, 6, 7, 8, and then we have an O. So here the chemical formulas are exactly the same. But if you notice, the OH in the one on the left is connected to carbon 2, while on the one on the right it's connected to carbon 3. So these would also be an example of isomers. Alright, and then we'll do one last example together. Again, please make sure that if you feel ready to do this, you guys just pause the video and try it out. Here, we can draw the skeletal structure, but the skeletal structure is going to look exactly the same as these Lewis structures because there are no carbons. So since there's no carbons, we would just write H, O, and then it's connected to an HO. And then here we have H connected to O connected to H. Okay, so this would be the skeletal structure because there are no carbons. And then obviously if we look at the chemical formula, there's 2 H's here, 2 O's here, so it'd be H2O2. And then we have 2 H's here and an O. So these two are not the same, so this would be an example of different compounds. So these aren't even isomers because the formulas are different. So this would be an example of different compounds. Alright, so hopefully that's helpful. I'm on the Zoom call right now, so if you guys have any questions, make sure you let me know, and good luck on your assignment. We'll see you next time.